All right, now this is the last recording for section 2.6, linear and absolute value inequalities. So this will conclude chapter 2, which is all material for test 1. All right. Now, when you're looking at inequalities, obviously there is an array of answer solutions that make the equation or the inequality true. So you have a multiple selection of answers. It's not just one answer anymore. So here, for an example, it says express the interval in set bill notation for this. Well, that means that the answer choices that we have here are from all the way from -9 through the value of 2, where the -9 is inclusive, whereas the 2 is exclusive. Why I say that is because the bracket means inclusive, where the parenthesis means exclusive. So this means it includes -9, and does not include 2. Excuse me. So now for interval notation, the way you do that is you go ahead and express it like this. So it's inclusive, so you're going to go ahead and put the value of -9 is less than or equal to x, but then it's less than 2. So it's not inclusive to 2. So this is what we're looking for set bill notation and how we're going to write that in there. Okay, so that's the answer we're looking for there. All right. So now it says grafting equality. Now the way you graph your inequality is you're going to go ahead and use a closed circle for values that are inclusive and then open circles for values that are exclusive. So when we look at the answer here, it's going to be inclusive to the -9, put a little dot there, and then put a line between these two, and then you have an open circle between so above 2. All right, and that's how you graph linear inequalities. All right, now this one has where it's 4 to infinity. That means that when it goes like that, it's x is going to be, and you point it to the right. I always think about pointing it to the right because it says that x is greater than 4. That's how we write that one. All right, so then of course for the set-bill notation, you always put a little line and then x, and then you go ahead and put it like that. So they're already giving you the x and the line, so you don't have to ever write that. All you're doing is looking for putting this as for your answers. So that's what you're going to type in there. Now for the value of the way you graph it on the number line, you're going to be exclusive, so you'd put a 2, or excuse me, you put a open circle at 4, and then you put an arrow that goes this direction. All right. I gotta go ahead and do it the right way, but anyway, the answer will be an arrow. I'm trying to get it to work, but it's not working the way I want it to. But anyway, you put an arrow and pointing it to the right. Okay, pretty easy to do this. Okay, now it says use a given graph for this. Okay, where is this line? Okay, which now you got to think about, this line is a positive value. It's going to be the darker, and it says the solid line, and then whereas this line right here is the dashed line. And basically saying, where is this solid line above, because it's greater than, the dashed line? And that would be from the value of -7 to infinity, because it's above it. It's higher than it. It's greater than it at these value systems. So the way you write that answer is going to be where, since it's not an inequality that is inclusive, in other words, it doesn't have an equal sign, you're going to have an open parenthesis. All right, so it's going to be open parenthesis negative. What is it? Negative? Yeah, -7. Okay, because it's negative there, on into infinity. So you just go ahead and put that in and put infinity. And you never put a bracket next to infinity signs. So that's our answer that we're looking for. All right, I typed that in. That's what you would want to write. That's how you use graphs to go ahead and determine value systems without any work, without any writing or anything like that. Okay. So, and then of course, graphing on the number line, you'd have the open circle at 7, and you point it to the right. So then the answer looks like that. So now solving the following inequalities. So we use graphs, now we're solving it. So solving it is just like anything else. We do not worry about the inequality, all right? We just solve it like we do a regular equation. The only thing that you have to be aware of when it comes down to inequalities is that anytime you're dividing by a negative, you must reverse your inequality sign. So let's go ahead and add 5 to both sides. And when you go ahead and add 5 to both sides, you're going to get 12, and then you're going to need to divide by -4. But when you immediately dividing by negative value, you must switch the inequality sign at that moment. Okay? So that's our answer that we're looking for. Now, what's it in interval notation? So how you write an interval notation is you're going to be inclusive to the value of -3. You're going to go ahead and point it to the right, and that means it's greater than the value of whatever we're talking about. So we're looking at interval notation as the inclusive bracket, -3 to infinity. All right, and then we're going to go ahead and to graph that. It's simple. You're going to go ahead and put a closed circle at the value of -3, and then you're moving it to the right. And then there's your answer, because it's always seeming that we get answers that are all greater than. Now, this is not changed in any way whatsoever. We're going to go ahead and add 42 to both sides, and then divide by 7, and then we get our answer. Okay, so I wanted you to be understanding of this, all right, that things will be what they are. Okay, so you just make sure that you are processing this. Okay, now this one does say it's less than, so it stays less than. So this is first one that stays less than. It's not greater than. All right, so that's why it's -infinity to 5. All right. I'm going to assume that you're not going to have any issues by just going ahead and adding 18, dividing by -6, and so on and so forth. If you have any questions on that, let me know. I want to bounce to something else right now, like say, for example, this one. You guys love fractions. All right, now with fractions, as before, you would go ahead and kill fractions as fast as possible. You want to go for the denominator or the LCD that's going to best eliminate the fractions. And the one that you're going to use is 10, because 2 times 5 is 10. So we're going to multiply both sides by 10, and then this will eliminate the fractions, because watch, 2 goes into 10 5 times. 2 goes into 5 10 times. Oh, excuse me, 2 goes into 10 5 times. And then you're going to go ahead and multiply this. 5 goes into 10 2 times. And then 10 times 7 is 70. So now there's no more fractions. All right. You want to practice that in good standing, because it's always helpful to eliminate fractions quickly. And then, I mean, the rest of this is your legwork. I mean, you subtract 2y from both sides. You're adding 5 to both sides, or subtracting 5, excuse me, and then so on and so forth. Okay. I'll let you do that. Now, for the next one, you would go ahead and multiply both top and bottom by 66, and that would eliminate your fraction there. Now, some good practice that I want you to get in hand on, I want you to go ahead and do it this way. If you can get some grasp over this, that would be good. When you multiply both sides by 66, this will go ahead and get eliminated and get 6. The one thing I want you to get a handle on is putting a 6 and then what you have here. And the numerator then jumps into parentheses. That's good habits. And when you multiply both both this side as well by 66. Okay, 6 goes into 66 11 times. So you're going to put 11 and then open parenthesis A plus 4. And then 66 goes into 66 one time. So then that's going to give us plus 1. So now you can go ahead and do the distributive property. See, you do 6A plus 12, and then you have 11A plus 44 plus 1. And then you go ahead and combine all like terms and solve for the variable A. Okay. So that's a little different. Okay. Now, when we're looking at number, and by the way, I mean, the rest of this you should be able to handle by yourself. You don't need me to give you the answer. You need me, I gave you some strong strategies on how to handle the beginning parts of it, which is what's going to trouble you. Now, when you have what we call a compound inequality like this one, where there's 2 inequality symbols, I always like to think of it as a waterfall. What you do, maybe a water fountain, if you prefer, want to say. Whatever you do in the middle, you do the outsides, and so you think about it as a waterfall, a water fountain. All right. So anyway, we're going to go ahead and add 4 to both sides. So we added 4 to both sides, like both sides and the middle, I should say. And then divide everything or all parts by 2. And then so you get -2 is less than x, but less than or equal to 7. And so our answer in interval notation would be exclusive to -2, but then 7 is inclusive. And that would be interval notation. So that's what we'll write in for here. And then, of course, graphing it, not a big deal. Graphing it shouldn't be challenging for you. It's either open circle or closed circle at the values that you write in here. And then put a line between them. Now, things don't change just because it's a fractions, all right? Now, what we could do, because fractions are very intimidating for people, is eliminate them first. But the problem, there is a slight issue with that. You have this middle term with 2 terms inside of it. All right, you have this expression with 2 terms. So we have to kind of be careful with how we go ahead and handle the LCD. So we look at 4 and 8, and we know it's going to be 8 is the LCD. So we're going to multiply everything by 8. And notice how I multiply both the left, middle, and right side when I do it. So now when I do this, I'm going to get 4 goes into 8 2 times, so I'm going to get -50. I eliminated the fraction of that, so I'm no longer have a fraction here. And then when I go ahead and multiply 8 times this, I'm going to have just 7x. And then I got to multiply this -1 by 8 as well and get -8. And then I go ahead and just wipe out my 8s and get 13. Now I no longer have any more fractions. I know that if you practice what I'm showing you here, that you're going to have good habits. And then once you develop these good habits, you can get more confident with fractions. Fractions are a pain because there's a lot more rules with them, but this one right here is probably the most beneficial and most used strategy to eliminate fractions so you don't make mistakes with them. All right, you shouldn't be freaked out about fractions. Now the rest of this isn't hard. All you can do is go ahead and add 8 to both sides, and then go ahead and divide both sides by 7. Yes, will you get fractions perhaps? That's okay. I mean, fractions are okay, but not all the time, and in this case we don't. Okay, just so you know. All right, wanted to point that out to you. I think that this is good here. Now let's look at this. A car rental company offers 2 plans for renting a car: $20 per day and 15 cents per mile. So let's write that down. It's 15 cents per mile, and then plus $20 a day. Then the other plan is $50 per day and 2 cents per mile. For what range of miles will plan B save you money? So when is it that this is going to cost you more money to get than this plan right here, which is 2 cents per mile and plus $50. So that's why I said, for what range of miles will plan B save you money? So it's when the value of miles is greater than such and such, and we need to solve it. All right. So what you do is you go ahead and subtract 2 from both sides, and go ahead and subtract 20 from both sides, and then just simply take your calculator, all right, and then take 30 divided by 0.13. So the 270, and it says rounds to nearest mile, so I'm going to say 231 miles. And 231 miles is exactly the answer. And so all I did was, again, take and try to find out what's the sweet spot. Take the 30 divided by 0.13. Okay? And that's all I did. So this will give you miles is greater than 231, because we rounded off to nearest mile. Okay? I know sometimes, oh man, word problems, they freak us out. You've got to get, down to reality of like just setting up a basic construction of a linear functions. All right, now, as I pointed out before, all right, you want to make sure that you understand this concept of you can't have negative values. But the thing is that this one is a little strange because it is no longer dealing with just one singular value. Okay, it's dealing with a range of values. So we have to kind of like think about that for a second, So now, when we look at this, we're going to do what we did before. We're going to practice that. All we got to do is remove the absolute value and then have the same inequality. But then we're going to go ahead and do this with these kinds of questions. All right. So our answer is from -1 inclusive, because it's inclusive, to +1. So I made that one look really silly because it wasn't, in my opinion, but there's other ones that are going to be more interesting. So here's your answers for that. Okay. Now, when we're looking at this, okay, we're taking the value of this. This is the best practice. Watch this. I'm going to go ahead and I'm going to set it with the same exact inequality symbol, put it at 16. Then I'm going to say less than or equal to, and then I'm going to put -16 on this side. So -16 is less than or equal to this. And now we're getting back to what we were dealing with, when we're dealing with this. So we're going to go ahead and just add 20 to both sides, divide by 4. So that I'm going to leave that one to you at that point. I'm giving you the strategy for when you handle inequalities. So your answers here would be 1 and 9, and then you have your arrangement. I'm not going to continue to just keep on beating a dead horse. You can figure out what to do from this point after I've set it up for you. Now it gets a little busier. Okay, we want to go ahead and recognize the busyness of this, but it doesn't make a difference. Watch how we process this. The first thing we do is subtract 13 from both sides and get -1. And then divide both sides by -8. And then we're going to get this. But watch this. Wait a second. Oh, did you notice it? All right. Just went ahead and switched the inequality symbol. Okay. And by the way, there's still this here. Okay. So now that we have that, all right, we then go ahead and set the contents of the absolute value to the other side. As well as the opposite of it. All right. Now, if you want, you can go ahead and multiply both sides by 8 and get this. And when you multiply both sides by 8, you also multiply the inside by 8. And now you have no more fractions. I mean, that's just one strategy you can use, okay? And then you're going to go ahead and still do everything you have to do. You have to go ahead and add 40 to both sides, and then you have to go ahead and divide both sides by 64. Okay? I want to point that out to you. Now, right, same thing goes for here. Once you go ahead and do this, watch this. You're going to take away the prints or the absolute value bars, and you're going to go like this. Put a -4 on the other side. And then you multiply both sides by 12, and then you get -4, the 8, and then you have this. Then you have 48 on this side. Now, I do want to point out something for you here. Whenever you're going to go ahead and do this, you're going to go ahead and add 6 to both sides. All right, and you have add 6 there. You're going to divide by -3. Remember what you do with dividing. Once you divide by -3, then this is going to have to switch the inequality symbol. So you're going to get -14, right? Or negative divided by negative is positive. So that's no longer negative. But then the inequality symbol must switch, and then you have the x. Inequality switches, you're going to get negative, and then that's going to give you 18. Now notice how -18 is less than 14, and this is kind of in a reverse way. So that what you want to do is you want to switch it so that it looks like this. All right, so that way it's set up properly. Now you go ahead and put in interval notation. You have it like this, and you're done. Okay, so there's your answer, -18, 14, and then of course graphing that here. Okay, so nothing really changed there. I just wanted to make sure I pointed out to you that fractions involve multiply. When you're dividing by negatives, make sure you switch the inequality symbol and then switch it at the end. That was pretty important what I did for you here. All right, and giving you the right tools to be successful with that. Now, when you have it where there's the less than symbol, it is a little goofy to write it this way. It's a little goofy. I don't like writing it this way. Whenever I have the, actually it's not the less than symbol, but the greater than symbol, I always go ahead and do the things that I always did. But I always say or, and then I say this. That's how I typically write it. Okay? Because when you have a greater than symbol, this is what's basically going to yield. You're going to have what I say when you can't see my hands, but it goes from it goes in opposite directions. This is the best way I could do it. I can't do it with my big hands in the video, but anyway, you're going to notice it goes like where then this means you're going to have an interval notation where it's from -infinity up to the value of -4, and then pick it up at 4 all the way to infinity. So this is where it goes ahead and goes in opposite directions. All right, one thumb goes that way, one thumb goes this way. Okay, and you had to use my shadow. That's pretty cool. Shadow. Anyway, sorry, my ADHD. All right, so make sure that you have this. Understood that you're going to use or instead of compound inequality, where it's banging into each other. Okay, where it's banging into each other, you're going to go ahead. That's with and or compound inequalities that we've been dealing with for quite some time. That's less than symbol. This is greater. Greater than symbol, it's going to go like opposite directions from each other. All right. Unless, of course, negative got involved. Don't try to play games with the system. If it's a negative sign involved, it switches the inequality symbol, and then that, don't overcomplicate it. Okay. At the heart of it, if the absolute value is all isolated and everything, and you have the less than symbol, then it's going to be an and compound inequality banging into each other. If it's greater than symbol, it's going to go in opposite directions. And there's a rare exceptions for simple rules, but I'm trying to give it to you in its most simple way. So this one's going to be an or situation, where it goes opposite directions. Okay, and the thing is, when you do this, you want to set it up as two separate problems. You don't want to put them together because it's a little goofy to put them together like I have been in the other one. So you're going to go ahead and say or this. When it's a greater than symbol, you're going to switch it to a less than symbol, switch the sign of the other side. All right, and then solve them independently. So you're going to go ahead and add 3 to both sides and get this, or you're going to go ahead and add 3 to both sides, you're going to get this. And by the way, you don't switch the inequality sign because you add or subtract and stuff. It's only with multiplication and division do you do that. So you add 3 to both sides, you get this. So that's why the answer is from negative infinity, because it says x is less than or equal to -3. So you're going to be coming from negative infinity going up to -3, inclusive. It's inclusive. And then you're going to connect it with the or. Since it's or, you're going to connect it with this. That's the end symbolization. Okay. Or I should say the or. End is, never mind. It's or. Okay. And then you have this. Okay. So you get that. The rest of this is pretty straightforward. This is the last question I'm going to go over, and I wanted to explain it to you. When you have an absolute value involved, what you're asked is use the graph, just like I kind of did with the other one, is you're asked, when is it that this graph, which is the solid line, when is it less than the other line or other graph, which is the 3 here, and that's the dashed line. So where this is less than or equal to this is at the interval of -1, because I'm going to go ahead and zoom in on this a little bit, from the value of here to here is when this line, this solid line, is less than the dashed line. If the interval or if the equation said when is it that this graph line is greater than or equal to this dashed line, all right, which is right here, because it's at the 1, 2, 3. That's the line we're looking at. When is it that this line is less than this line? So it'd be below it. But if it said greater than, it would be from negative infinity to -1. And then from 9 to positive infinity, because that's when this line right here would be above or greater than the dashed line. So you have to be careful with what you're reading. And they want us to use the graph, use the given graph. That's the whole thing. And you don't have to solve anything here. We don't have to do that. All right. And that's all you have to do. And so there's the answer. All right. Something to try to get used to. All right. Well, that's going to be a conclusion for lesson 2.6. And I'm hopeful that it gives you enough tools and strategies to be successful in completing this. I've gone over a lot of different strategies with you, and I hope you're successful. All right, I'll talk to you later.